Hi folks, hope you're doing well today. I want to talk about solving systems of equations using the substitution method. So in the last time we talked about solving a system of equation. We graphed each of these linear equations, and remember the possibility is they can either cross in one point, one xy value makes both equations true, or they cannot cross at all and it's two parallel lines and there's no solution. Or the third possibility is that these two are the same line and they cross in infinitely many locations. Now I want to talk about an algebraic method to solve system of equations, and there's really three different ways to solve systems. You can solve by graphing, you can solve using the substitution method, which is what we're going to do now, or you can solve using the elimination method, which is in the next video. And that any of these ways is a valuable way to solve. And of course, I'm teaching you three different ways because sometimes one way is better than the other way. But to solve for substitution, let's follow the steps. First, we're supposed to solve one of the equations for either variable. So either in the first equation, x plus 3y equals 10, we solve for x or y, or in the second equation, 4x plus y equals 18, we solve for x or y. Now here's what I'm going to do. In the first equation, if you'll notice, this x right here doesn't have a coefficient, which actually makes it easier to solve for. So what I'm going to do again is go with the first equation, x plus 3y equals 10, and I'm going to solve it for x. And it's only because there's no coefficient times the x. It's really a 1, right? Now, to solve, I have to get the x by itself, so I'm going to subtract 3y from both sides. That gives me x is equal to 10 minus 3y, or you can write that as negative 3y plus 10. So we've done step 1. Step 2, it says substitute the expression from step 1 into the other equation. Now what's the other equation? Well, that is your 4x plus y equals 18, so I'm going to go 4x plus y equals 18. I'm just writing it down. Now what I'm supposed to do is replace this x right here with what x is, which is 10 minus 3y. You follow that? So now I'm going to have 4, which is already in my equation. Remove the x, replace it with 10 minus 3y. Rewrite the rest of the equation, plus y equals 18. So step 2 done. Step 3, solve this resulting equation. So I'm supposed to solve. Now notice there's only y's in the equation now, which means it's solvable. So 4 times 10 is 40. 4 times negative 3y is negative 12y. And then the plus y is out here equals 18. Remember, now I need to combine like terms. So 40 minus, now negative 12 plus, remember there's a 1 right there, is negative 11y equals 18. I need to get the y by itself, so I'm going to subtract 40 from both sides of this equation. I have negative 11y is equal to, now 18, subtract 40. You can think about that as 18 plus a negative 40 is going to be negative 22. And let me write here what we have. We have negative 11y equals negative 22. Now when I solve for y, divide both sides by negative 11. So I get y is equal to, now negative 22 divided by negative 11 is positive 2. So now step 3 is done. Now step 4 says substitute the solution from step 3 into one of the original equations to find the other variable. So I'm going to take y equals 2 and plug it into either the first or the second equation. It doesn't matter. I'm going to go with the first one because it's written first. X plus 3 times 2, because y is 2, equals 10. That gives me x plus 6 is equal to 10. I'm going to subtract 6 from both sides of my equation to get x is equal to 4. And then there's my solution right there. So my solution is 2, No, it's not. X first, right? 4, comma, 2. Notice it says write it as an ordered pair. That's what I did right there. And then step 6, which I did not leave myself any room to finish, but we're going to do it anyway, it says check it. Now we learned how to check in the last section where we just solved systems of equations. Let's check this thing in purple. So I'm going to go to the top right of the page. It says x plus 3, y equals 10. My x is 4 plus 3. My y is 2. Does that equal 10? Well, 4 plus 6, yes, that equals 10. Let's check the next one. 4 times x is 4 plus 2. Does that equal 18? Well, 4 times 4 is 16 plus 2 is 18. Notice it checks out just fine. Okay, you ready to try another one? So notice the direction, solve the system of equations using the substitution method. Now, sometimes it just says solve the system of equations. In that case, you can use the graphing method, you can use substitution, or you can use the yet learned elimination method. You're going to decide which method is best. This problem we have here is definitely best by substitution. Let me show you why. You notice right here, the second equation, it's already y equals. So the first step, solve one of the equations for either variable, already done. So this is the perfect problem to use the substitution method. So what I'm doing is I'm writing down the first equation. And what I'm going to do is substitute y equals negative 3x minus 6 for this y right here. That's going in that spot. So I have 2x. The minus stays in front, and then I need parentheses. The parentheses are required. Every time you use substitution, please use parentheses. So 2x minus y, and then I rewrote y as negative 3x minus 6 equals 1. Now if you'll notice, we have the the first equation written down with the y taken out and negative 3x minus 6 substituted in, and it has only one variable in it, just x's. There's no x and y, which means we can solve. Now to solve, though, I have to use the distributive property. That's always going to be the next step, by the way. I have to do, what am I distributing? Remember, there's a 1 right there. There is an implied 1. So when I distribute, I'm going to be multiplying this negative 1 in the parentheses. So I have 2x. Negative 1 times negative 3x is plus 3x. Negative 1 times negative 6 is plus 6 is equal to 1. Then I'm going to have a like terms situation every time. So 2x plus 3x is 5x plus 6 is equal to 1. I'm going to subtract 6 from both sides of my equation. I get 5x is equal to negative 5. Then I divide by 5 on both sides, and I get x is equal to negative 1. So that takes us all the way down, by the way, to here. Solve the resulting equation. Now I'm at step 4. I've got to find the other variable, which is y in this case. So to find y, I'm supposed to take my x equals to negative 1 and substitute into either equation. Honestly, it doesn't matter to solve for y. Now, in this case, I'm liking the second equation. The reason is, it doesn't matter now. But the second one is already y equals, so I do negative 3, take out the x, replace it with what we found, negative 1 minus 6. I think the math's a little easier. Negative 3 times negative 1 is positive 3 minus 6. And you know that you can do the keep change, right? And that gives me negative 3. So y is negative 3. So my answer is going to be x first, which is negative 1, y is negative 3 in ordered pair form. Finally, I can check it. So I have 2, my x is negative 1. I'm looking at the first equation, minus a negative 3. Does that really equal to 1? 2 times negative 1 is negative 2 plus 3 equals 1. That checks, right? Then we check the second equation. So y, which we have is negative 3, is that equal to negative 3 times negative 1 minus 6? Is negative 3 equal to 3 minus 6? Yeah, negative 3 is equal to negative 3, and that checks out. So right in the middle of the page, highlighted in aqua, negative 1, negative 3 is our final answer. The green, again, is just checking it, doing step 5. So I've got to third solve the system by the substitution method. What I did this time is I eliminated the steps because we've got this down, right? So what I want you to do when you first get started is find the variable that you want to solve for. You're always going to have 4 choices. So you can solve for x or y in the first equation, or you can solve for x or y in the second equation. And my favorite, and it doesn't matter, honestly, any of the 4 is fine, but there is one in this case easier than the others, and that is that y right there. Why? Because the coefficient of that y is a positive 1. Like here's a negative x. We could solve for it, but we're going to have to divide everything by -1 to make it positive, or move it to the other side. Same thing with this negative y down here, but if I solve for the one I have highlighted, then all I got to do is move that x to the other side. So here's where I'm starting. -x plus y is equal to 4. I want that x on this side. You know what to do. Change the sign and move it over. There we go. And you could write 4 plus x or x plus 4. So now I take that y that's equal to 4 plus x and make sure you go to the other equation. So this y equals 4 plus x is going to go into this y right here. Okay? Not this one. That's the one we solved for in the beginning. So now I'm going to take 4 plus x and plug it into 4x minus y and replace it with 4 plus x equals 2. So here we go. So second step, I want to change colors on you. So you have 4x minus, remember parentheses. You always substitute with parentheses around where you're substituting. Okay? So that's 4x minus y is equal to 2. And my y is 4 plus x. Next step is the distributive property. Remember, that's a 1 right there. And so I'm distributing the -1 inside. That gives me 4x. -1 times 4 is minus 4. -1 times x is minus x equals 2. Next step is like terms. So this 4x minus 1x is 3x minus 4 equals 2. Remember, you're solving for x, so we're going to add 4 to both sides to isolate that x on one side. That leaves me with 3x on the left. The 4's cancel, 6 on the right. Now I divide by 3, and that gives me x is equal to 2. Now the next step, remember, is to take that 2 and substitute it into the second equation. So I have 4, or the first equation, it doesn't matter. I'm just going with the second one. So 4 times x is 2 minus y is equal to 2. Gives me 8 minus y is equal to 2. I'm going to subtract 8 from both sides of the equation. That gives me -y equals, now it's 2 minus 8, or 2 plus a -8. We know that's -6. Don't forget when that has a negative in front of it, you have to divide by -1. So y is positive 6. I write that as an ordered pair. Remember, I've done that every time with x first, which is 2, y next, which is -6. And then I really can't emphasize enough the check it. You can check every one of these problems to make sure you have it right. So you plug it in the first one. So -x plus y equals 4. That would be -2 is my x, plus y is -6. Does that equal to 4? Now I have a typo, right? -2. No, I have something wrong. I see what I have wrong. Do you see what I have wrong? It took me a second to find it. I copied wrong. Y equals 6. When I come down here, that's y equals 6. I just added, when I wrote my ordered pair, I wrote it wrong. So when I check it, that's 6. -2 plus 6 is 4. And this is exactly why you should check your work. Something as simple as just copying a positive 6 and turning it into a -6. I have no idea why, but you would get it wrong. So you can always check these. I'm checking the second one. 4 times x is 2 minus y is 6. Does that equal 2? That's 8 minus 6 is 2. Yep, that checks out just fine. So we know now we have this one correct. So let's continue. It's all about practice at this point. I've shown you the steps. There are no tricks beyond what I've shown you. They do get more complicated, and we haven't run into a problem where we get no solution or infinitely many solutions. So hang with me till we get to that point. So when I look at these two equations, I'm either solving for this x, this y, or this x, or this y. Which one's the easiest? If you have the option of a variable that has a 1 as a leading coefficient, like that one that I just highlighted, the 1x, that's the easiest one to solve for. So I'm going to start with the first equation, x minus 6y is equal to negative 6, and I'm going to solve it for x by adding 6y to both sides. Or we can just think about how we have been thinking about it and move the 6y to the other side. It changes sign. So negative 6 plus 6y. Those are not like terms, right? So I can't combine them together. Now I'm going to take this x and plug it into the second equation for that x right there. So now I have 2 times negative 6 plus 6y, because that's 2 times x, and x is negative 6 plus 6y, minus 4y is equal to 4. Next step is always the distributive property. So 2 times negative 6 is negative 12. 2 times 6y is 12y, minus 4y equals 4. Then you combine like terms. Negative 12 plus 8y is equal to 4, and then you solve for y. In this case, we'll add 12 to both sides. That gives me 8y is equal to 16. I divide both sides by 8 to get y is equal to 2. So we're halfway done. Now I just take that y equals 2, and I substitute that into either the first or the second equation. I'm just going with the first equation. X minus 6, y is 2, equals negative 6. That says x minus 12 equals negative 6. Now to solve for x, I'm going to add 12 to both sides of this equation. Gives me x is equal to 6. Alright, so I write my answer down. That's 6, 2. I had to stop for a minute and make sure this wasn't the same as the last problem we did. The numbers look very similar, but they're in reverse. Now I need to check it, okay? So I'm going to check my work. Let's check in purple again. So I've got x minus 6y equals negative 6. My x is 6 minus 6 times 2. Is that really equal to negative 6? Well, that's 6 minus 12. That's definitely equal to negative 6. And I check it in the second equation. So 2 times 6 minus 4 times y is 2 equals 4. That's the question. Is that true? That's 12 minus 8 equal 4. Yep, that's true. And here's the thing about checking. More than likely, if you've got this wrong, it's probably going to work for one equation and not for the other. Now, that's not a certain, but a lot of times your mistake comes in maybe the green part of the problem over here, which means it might work for the first equation and not for the second, or vice versa. So just keep that in mind. When you check it, don't check just one equation, check both of them. That is required. Okay, this is an unusual problem, but notice what we have is you're trying to have a variable isolated already, or get one easily isolated. And look, both equations have y isolated. Notice right here, it's already y equals, and right here, it's already y equals. So what do? Well, I'm going to plug in this y value right here into that y value right there. So I have 1/4 x is equal to negative x plus 10. No more y's, right? One y subbed in for the other y. Now it turns into a problem like we did quite a ways back, where we need to clear fractions. We want to completely clear the fractions out of this so we don't have to worry about that 1/4, which means I'm going to multiply, watch this trick, every one of these terms by 4, which is the least common denominator. So I'm going to multiply the first term by 4, the second term by 4, and the last term by 4. I put little bitty 4s, that's really just multiplication. So 4 times 1/4, the 4's cancel, and that just gives me x, or 1x. On this side, 4 times negative x is negative 4x, and then 4 times 10 is 40. Now, notice I have x's on each side of the equation. This is the first time we've run into this issue, because it's the first time we've ever had y equals and y equals. But I need to add 4x to both sides, so all my x's are on one side. Cancels on the right, moves over to the left, and now that's 5x is equal to 40. I divide each side by 5 to get that x isolated. It gives me x is equal to 8. So I know x is 8. How do I find y? You take that x is equal to 8, and you can either go to the first or the second equation and plug that in to find y. I'm going to do the first equation. Y is equal to negative 8 plus 10. So y is equal to 2. When I write that as an ordered pair, it's 8, 2. Remember, x first and then y. That should be my answer, but it's not really official until I check it. So let's check our answer. So I have y, first equation, 8, equal to negative 2 plus 10. That is true. Second one, y, which is 2, is that equal to 1/4 of 8? That's true too, right? 1/4 times 8. Multiply those together. 1 times 8 is 8. 4 times 1 is 4. That is definitely equal to 2. Okay, I have 3 more problems for you to take a look at. So remember, the idea is to, out of one of these 4 variables, x in the first, y in the first, or x in the second, or y in the second, which is the easiest to solve for? If I ever have a choice, I pick the one that doesn't have a coefficient. Really, it's a coefficient of 1. So I'm going to pick that highlighted y. Now, it still has a negative in front of it, so we still have work to do with it, but it's not bad. Now, I did want to show you something, though. If I have 4x minus y equals 0, can't I just add that y to the other side and get 4x is equal to y? That works, right? I moved the negative to the other side and made it positive. So now I know that y is 4x. So what I'm going to do is I'm going to remove the y in the second equation and plug in 4x instead. So now I have 2x minus 3. I'm taking out the y. I'm substituting in 4x is equal to 5. That gives me 2x minus 12x is equal to 5. I have like terms. That's negative 10x is equal to 5. I divide by negative 10. And I get x is equal to, now careful here, that's not negative 2, right? This is a fraction. A positive divided by negative is a negative. And then 5 divides by 5, and 10 divides by 5 to give me 1/2. So my x is a fraction negative 1/2. Is that okay? It is. It happens pretty frequently that you get fractions as answers. And this is the reason the graphing method, it would not be the best for this problem. Because if you end up with fractions as answers, being able to determine that by looking at a graph is not an easy task. Okay? So what do? Now I take that x is equal to negative 1/2 and I plug it into the second equation. So 2 times negative 1/2 minus 3y equals 5. Now this simplifies nicely. The 2's cancel. So I have negative 1 minus 3y equals 5. Remember, the goal is to solve for y. So I'm going to add 1 to both sides. I get negative 3y is equal to 6. Divide both sides by negative 3. And I get y is equal to 6 divided by negative 3 is negative 2. Which means my solution, unchecked, but my solution is negative 1/2, positive 2. Negative 2. 6 divided by negative 3 is negative 2. I almost made a mistake there too. Now let's check it. So purple check. There we go. So first equation, 4 times negative 1/2 minus negative 2. Is that equal to 0? Okay, well 4 times negative 1/2 is negative 2. Positive times negative is a negative. The 4 is over 1. You see how that works. Negative 2 plus 2, because the 2 negatives, equals 0. Yes, that checks. Now let's check the next one. 2 times negative 1/2 minus 3 times negative 2. Is that equal to 5? 2 times negative 1/2, again, the 2's cancel. I get negative 1. Negative 3 times negative 2 is plus 6. And you know what? Negative 1 plus 6 does equal 5. So we got it right. All right, this is the next to the last problem. Okay? And this one looks like a booger. Here's why I say this. I have 5x and 2y right here. Neither of those is just x or just y. Same thing in the denominator, y and x. So what do we want to solve for? Honest to goodness, it doesn't matter to me. I'm just going to solve for this x first. They're all ugly, okay? But that's okay. We're going to get there. Don't worry about it. It's going to be fine. So what I'm going to do is I'm going to write my equation down first. 5x plus 2y equals 12. And keep in mind I'm trying to solve for this x. So I'm going to minus 2y on both sides. Or you just move that 2y to the other side and change the sign. So that's 12 minus 2y. Now I have to divide everything by 5. That's no fun. But we can do it. Now when I say divide everything by 5, you could have divided each of these by 5 or leave the 5 underneath the whole fraction. It doesn't matter. I'm just going to leave it underneath. Okay? Alright, now that's my x. What am I going to do with it? I'm going to pick it up and I'm going to plug it into that x right there. It looks like a big mess, doesn't it? But it's okay. We'll get it. So negative 4y minus 10. And remember, I'm taking out the x and I'm plugging in 12 minus 2y divided by 5 equals negative 24. Now, the great news, and this does not always happen, by the way, that, look, this 5 and this 10 cancel to leave a 2. So I don't have any more fraction to do with because I did 5 goes into 10 twice, 5 goes into 5 one time. So now I have negative 4y minus 2 parentheses 12 minus 2y is equal to negative 24. And now I use the distributive property. So I have negative 4y minus 24 plus 4y is equal to negative 24. Now look, negative 4y and plus 4y cancel out when I have like terms. I get negative 24 equals negative 24. Do you remember what that means? Well, first of all, I have this idea of an identity. This is an identity equation. What that means is I have the same line. There are infinitely many solutions. Now, you'll have to pay attention to how the homework reads, how they want you to answer that question. All 3 of these answers are correct. This is an identity. It is the same line if you're thinking about this geographically, if you're going to graph it, okay? And it has infinitely many solutions, and algebraically infinitely many solutions is probably the best answer to this problem. You can't check those, by the way. So that's as good as it gets. You can redo the work, but you can't actually check infinitely many solutions. And for our last problem, so you're looking at your 2 equations, and you want to solve for x or y in the first or second equation. Check out the second equation. Notice that y is already solved for. So what am I going to do? I'm going to take that value, which is 5/3 x minus 4, and plug it into the y in the first equation. So I have 5x minus 3 times 5/3 x minus 4. The next step is to use the distributive property, right? So, we're missing an equal sign. This is equals 2. So I need to use the distributive property, negative 3 times 5/3, and then negative 3 times negative 4. So I have 5x. Now look, if you don't like the way that looks, just write it down separately. Negative 3 times 5/3 x, and then minus 3 times negative 4 equals 2, and then simplify. So now I have 5x. The 3's cancel. That gives me negative 5x plus 12. This negative 3 times this negative 4 is plus 12 equals 2. Now, what has happened? I got 5x cancels with 5x. And I have this statement that makes no sense, right? 12 equals 2. Now, when you're solving an equation, remember we call this a contradiction. But when you're solving a system, we have no solution. And graphically, what that means is we have parallel lines. Now, often when you have no solution, you would enter it as the empty set. But this really is the best answer algebraically, but depending on what your homework says to do, the empty set might be how you enter that. So I hope this helps. These require a lot of practice, And we'll return one more time to talk about solving systems of equation using the elimination method.